So now that we've talked about how to visualize what's going on, let's actually take a look at the real code. And again, a lot of this stuff may be sort of obvious, but for completeness, I just want to make sure that you've seen it, because your code will look something along these lines when you do it for your assignment. So this is this is the implementation of process stream. We'll look at process input in a second. And one of the things to note here is that there's one minuscule change compared to the sequential version. So if you went and looked at the sequential version, you would see it has .stream here, not .parallelstream. That's the only difference in that method. And what we do when we use .parallelstream is, under the hood, that uses the ArrayList splitterator. ParallelStream uses the ArrayList splitterator in order to create a parallel stream that will take the works of Shakespeare and then map it to all the underlying worker threads in the common fork join pool. So it's going to split up the input list into these chunks. Each input string is thus processed in parallel using the common fork join pool. So if you think of this being the original works of Shakespeare as one list of strings, we split it until we get to each string being an atomic-sized unit of 1. And that's the default behavior of splitterators for collections. If you don't like that, you could change it, but that's what you do out of the box. So then all those things are going to be run in parallel in the common fork join pool. What happens next? As you can see, we use the map intermediate operation, passing in the process input method reference, which is going to search a given input string to locate all the occurrences of the phrases. And again, if you look at the sequential version, it looks exactly like this, but it just says .stream instead of .parallelstream. And then finally, we have collect with toList, and that triggers all the processing and then merges all the results into a single list of lists. And there's a couple of things to note here, which I didn't really talk about in the visualization slide, but now we're in the implementation slide. We can go into more detail. The toList factory method is part of the collector's utility class, and it returns a so-called non-concurrent collector that obeys in counter order. What's a non-concurrent collector? Non-concurrent collector sounds at first glance like something that shouldn't be used with a parallel stream because it's non-concurrent. Well, it turns out that a non-concurrent collector works perfectly fine with a parallel stream or a sequential stream because of the way the collector framework is designed. And all it means is that there's no need for any synchronizers in the collector implementation, in particular in the so-called accumulator portion of the collector implementation. And that's because parallel streams arranges so that the collector is never simultaneously updated by multiple threads. Instead, it collects everything within a thread, and you get a bunch of these collectors. And then when the combined phase occurs in the streams environment, in the streams framework, then those elements that have partial results are successively merged together and combined to lead with a final reduced result at the end. And so that's why we don't need to have any synchronization, and we can use a non-concurrent collector. When we talk later about concurrent collectors and non-concurrent collectors, you'll get a better feel for how this all works. But the good news is it works. So let's take a look now at how you'd implement the process input method as a parallel stream. Here's what the implementation looks like. You can see it's just a little bit more detailed than the visualization, which is perfectly fine. Once again, however, there's just a tiny little minuscule change, and that is this. So what happens in the process input method, you give it the work of Shakespeare, and we have a little helper method that goes and extracts the title of the work from the work. It uses some cool regular expression matching that I don't want to talk about right now. And then we grab the rest of the work using a subsequence operation. So we have the title and the work, the actual words in the play and people speaking in iambic pentameter and all kinds of good stuff. And then we take that input, and then we use the mphrases to find field, which is a list of phrases to find, hence the name. And that uses parallel stream, which uses the ArrayList splitterator, because mphrases to find is an array list, to create a parallel stream that will search the input to locate all the phrase occurrences in parallel. And so we now have a stream of phrases to find. And then what we do is we use our good friend map, which is the workhorse intermediate operation in the streams environment. And we call a helper method called search for phrase. And search for phrase does some really, really cool things, which we'll not talk about in detail at the moment. But basically what it does is it takes the phrase we're looking for, the input string, the work of Shakespeare, the title of the work of Shakespeare, and then a flag that tells whether or not search for phrase should search in parallel or not. And I will defer that discussion until later because it's outside the scope of this talk. But basically, if you put in false, it'll make a sequential search in parallel. But if you put in true, it'll do a parallel search in parallel, which is very cool. We'll talk about that later. At any rate, we go and look up the phrase. That's going to return a search results object. And then we go ahead and we filter this to get rid of things that are not there. But the thing to note is that all this stuff also runs in parallel in the common fork join pool. So we're, again, parallelism in 2 dimensions. The strings are being run in parallel, and then for a given string, the phrase searching is being done in parallel as well. And when we're done, we go ahead and collect everything up into a list, which triggers the processing and merges everything together into one list, once again using a non-concurrent collector. And then the final thing we do is we return the list of search results. And honestly, I might even do this in my code now. I may just return that. I just may say return mphrases defined and have my stream. I only wrote it like this so I could kind of say, oh gosh, look, we're returning the results. But normally we wouldn't have a local variable here in such a situation. We would just go ahead and return the result of that stream. And you'll probably notice that also on some of the comments I may have given you on your code. You may not have done that, but some people were defining a lot of extra local variables which aren't necessary and just kind of confuse things. The code's not wrong, it's just more unwieldy and verbose than we might want. So that's a quick overview of how we can implement the search with parallel streams hook methods using parallel streams features. And now you definitely have enough information to do your assignment because your assignment's going to look very much like this.